see if we can follow the steps given to us by Reed to solve this equation. So first we're going to multiply both sides by dt. Now if that seems really dodgy to you, then that's probably a good thing, because it is, and I've made another video where I mathematically hopefully justify what I'm doing here, but for the purposes of this video I'm just going to go through the steps that you need to make to solve the equation. Okay, multiply both sides by t. Next, we need to check whether there is a term with theta in with the dt. Here's the dt, and yes, there is a term with theta in with the dt. It's theta minus 70. So what we need to do is divide both sides by that term. Okay, let's do that. 1 over theta minus 70 d theta equals, I'm going to write it as 1 over theta minus 70 d theta minus, rather than d theta over theta minus 70, because it's going to be nicer later. And we're left with minus k dt. K is just a number, so that's not a term to do with theta. Okay, we're done. If there is a term with t in with the d theta, that should say, let's put a d in there. Silly Reed, you forgot that d there. In with the d theta, then divide both sides by that too. So here's the d theta here, but nothing, we've got no terms here to do with t, so that's fine. Okay, that's that one done. Integrate both sides. Okay, that's fine. We can do that just by putting an integral sign on and integrating with respect to the correct variable. So on the left we're going to get ln of theta minus 70, and on the right we're going to get minus kt, because we're integrating with respect to t, and it says you only need to plus c on the right hand side. Again, in the other video I've explained why, if you're interested, why you only need to put the c on the right hand side. Okay, that's number 3 done. 4. If you have any particular information about what theta is at a particular time, then you can sub that in. Okay, so say we do a measurement when we first turn up, when Reed and Morgan turn up and find the dead body, and they find that the temperature of the dead body is like 94.4 degrees Fahrenheit. Okay, well we can sub that into our equation. That means that ln of 94.4 minus 70 equals minus k times 0. 0 is the time that they turned up and found the body, took the temperature, plus c. So that tells us what c is. C is ln of 24.4, whatever that is. So our equation connecting the temperature and the time is now ln theta minus 70 is minus kt plus ln 24.4. Now 10 minutes later they take another temperature and they find out that the temperature is now reduced to 90 degrees Fahrenheit. So let's feed that information into our equation. Ln of 90 minus 70 is minus k times 10 plus ln of 24.4. Rearranging that, we can get k equals 1 over 10. Ln, I think you should be able to rearrange this into this form, 24.4 divided by 20, whatever that is. So what does that give us? It gives us an equation, this equation here, but we now know what c is and we know what k is. So we know c, we know k. Now that equation gives us a link between any time and the temperature. Now we know that a human body at the time of life is roughly, what is it, like 98.6 degrees Fahrenheit. So if we put 98.6 degrees Fahrenheit into here, then we're going to get out a value of t that will be negative, and that value of t will be the number of minutes before the police arrived that the person died. See if you can work out what it is, and then I'll put the answer up. Did you have a go? Well, I got minus 1.07. So, time of death, 1.07 minutes before Reed and Morgan turned up. So they only just missed the murderer. Let's try this one. So we're going to multiply both sides by dx in this case, not d theta, because it's dx down here. that will give us dy is 9x plus 6 times y to the third, all divided by x, dx. Okay, next job. If there is a term with y in with the dx, then divide or multiply both sides by it to get it to the other side with the dy. Now, that means we're looking over here. Here's the dx. Is there anything to do with y here? Are there any y terms? Yes, there is. There's y to the third. So I need to divide both sides by y to the third in order to get that off that side with the dx. So then I get 9x plus 6 over x dx. Okay, that's that one done, number 2. Oh no, it isn't. I didn't check the other side. If there is any terms with x in with the dy, then divide or multiply both sides by that too, so it's with the dy. Okay, are there any with the dx, that should say? Reed's making all sorts of mistakes today, in with the dx. Okay, are there any terms on this side to do with x? No. So all the terms to do with y are with the dy, all the terms to do with x are with the dx. Brilliant, now we can integrate. So it's y to minus a third dy is the integral of, I might just tidy this up a bit using the v, 9x over x is 9 plus 6 x to the minus 1 dx, so that gives us y to the 2/3 with a upside down 2/3 there, equals 9x plus 6 ln x plus c. Now, final job will be to use any information we've got for y and x to find out what c is, but in this question I haven't given you any information, so your answer would be left like that. Or if we wanted to be really fancy, we could try and make it say y equals. So let's double everything and divide by 3. Y to the 2/3 is 18 over 3, which I can probably simplify, x plus 12 over 3, which I can definitely simplify, ln x plus 2/3 c. Then we can we can cube it and then square root it. Actually, we can just put it all to that power. 18 over 3 is 6, 4 ln x plus 2/3 c, all to the power of 3 over 2. And then we've written it explicitly. The solution is explicitly written as y as a function of x. This one looks fun. Okay, let's start by multiplying both sides by dx. 2 cot x dy equals, I've just remembered that should say dx, equals 4 minus y squared dx. We better put brackets around that 4 minus y squared so it doesn't look like 4 minus y squared dx. It's 4 minus y squared dx. Okay, what's the next job? Make sure that we haven't got any x's in with this dx. Sorry, any y's. Oh my goodness, any y's in with the dx. And we've got a term involving y's in with the dx. So I need to divide both sides by that so that that's not on that side anymore. So that will give me 2 cot x over 4 minus y squared dy equals dx. Right, next job. We need to look on the other side and see if there's any terms with x in with the dy. Are there any terms to do with x here? Yes, there is. There's a cot x term. So I need to divide both sides by cot x, giving me 4 minus y squared dy equals 1 over cot x dx. Okay, and now I'm fine because the dx has only terms involving x and the dy only has terms involving y. So now I can integrate both sides, and you can just stick an integral sign on like this. Okay, how are we going to integrate this? Well, on the left-hand side, we've got what looks like a scary fraction, but you should recognise straight away that the bottom factorises. And on the right-hand side, we've got what looks quite scary, but 1 over cot is just tan, so it's tan x dx. Now, they might both still look very scary to you as integrals go, but this side, we can use partial fractions to pull apart those two factors on the bottom, and on this side we can use spot the dog, we can spot the derivative, because this is the integral of sine x over cos x. And sine x is the derivative of cos x. So we've got the derivative of a function on the bottom, its derivative on the top, so that's come from ln. So I'll do the fiddly work with the partial fractions and then just show you what they look like, but if you want you could pause the video and have a go. So after we do all the partial fractions, we get a half, and then integral 1 over 2 minus y plus 1 over 2 plus y dy equals integral, and then you can see the spot that derivative there, the sine x is the derivative of cos x, so that's come from ln. So our final answer would, well, not final but almost, is a half, and then we've got ln 2 minus y, but we need a minus sign in front of that to compensate for the minus sign inside, plus ln 2 plus y equals ln cos x, and again we need a minus sign there to compensate because the derivative of cos is minus sign, and then there's that plus c. Now obviously you can use your laws of logs, you can fiddle around with it, you can rearrange it, you can write it in lots of different forms, but basically this is the solution to the differential equation. Final example, we're going to multiply both sides by dt, because that's the thing we've got at the bottom now, not dx, it's dt. So we're going to multiply both sides by that, leaving us with 75 dh equals 4 minus 5h dt, and we need to bracket that 4 minus 5h to make sure that we know that it's all being multiplied by dt. Now we're going to check whether or not on this side, where there's dt, there's anything involving an h, and yes, there is. There's this whole term here, 4 minus 5h, that's one term. You can't just consider the minus 5h, it's this whole term, 4 minus 5h. So we need to divide both sides by that. 75 over 4 minus 5h dh equals dt. Now we need to check the left hand side. Is there anything to do with t on this side, because it should be over there? Anything to do with t? Nope, that's all fine, that's all numbers. Okay, we can go ahead, integrate both sides. On the left hand side we get ln of 4 minus 5h. We need to compensate with a minus 1 over 5, and we've got a 75, oops, haven't got room, 75 on the top there. Let's just move that across a little bit. So we've got the ln of the bottom, we've got a minus 1/5 because of the minus 5 here that would come out as the derivative of the baby in the chain rule, and we've got a 75 there which also needs to go on the top. That equals, well, we're basically just integrating the number 1 with respect to t, so that's t plus c. And then we could rearrange it, we could times both sides by whatever 75 divided by 5 is, and then do e, and then rearrange, we could do all that. But essentially this is the solution if we want to stop there.